This demonstration will illustrate how SpaceClaim can be used to reverse engineer a gear. We'll start by using an STL file, which is a faceted surface representation of the geometry, and we're going to use that as a guide to rebuild a new geometry from it. There is an option to directly convert the STL surface into a 3D solid. However, if you do that, the geometry is going to be very poorly representing what it should be in reality. And that geometry is a little more difficult to clean up than working with the STL file directly. So that's the approach that we're going to take here. And we'll bring this geometry into SpaceClaim. This is what SpaceClaim looks like, where we have a bunch of tabs up on the top, and in each of these tabs there's a ribbon of icons. And the larger icons are the ones that we use quite often to do most of the operations. And in this demonstration we'll pretty much use pull, move, and fill combine. We'll basically do everything that we need to do to rebuild a 3D geometry from this STL file. So right now we have our gear. It's a faceted mesh, and like I said before, you can directly convert that to 3D solid, and if we do that we'll see what we end up getting, which is a pretty poor representation of what this geometry should look like. So like I said before, we're going to just use this as a guide to rebuild our geometry. So to start off with, the high-level approach that we're going to take is to extract a cross-section from this gear. That cross-section we can revolve around, and then we'll come in and create a solid that represents the cutter for each gear tooth, and we can subtract that out from the revolution, as well as we can subtract out these holes. So that's the high-level approach that we'll take to use this STL file and rebuild geometry from it. So since we're going to do that, I'm just going to slice this STL model into a smaller sector just to make it a little bit easier to work with. So to do that, if I just click on the global origin and then insert a plane, from that we get the 3 orthogonal planes off of that coordinate system. So I'm just going to take this one plane that we have right here and then pattern it to make a bunch more planes that I can then slice the STL file with. So I can simply click in the direction that I want to move this plane to create the pattern, and then once we create this pattern, that shows up in our structure tree. So in the details down here I can then put in 15 degrees for planes, and then I will use the planes to slice out just this one section of the geometry. So to slice the STL, there is a faceted data toolkit in SpaceClaim, and this ribbon of icons has a bunch of utilities that work with modifying the STL geometry. I'm just going to simply split the STL file with a plane. So go through here and then split that. Now I have just one small repeatable piece of this geometry, and I just want to hide that piece, select everything else, hit the delete key on the keyboard, and then show everything else. So then that will just leave us with this one small section. So now the first thing that I said that we were going to do is we are going to extract a cross section from this STL geometry, and that can be done with the insert tab, and then there's a reverse engineering section, and one of the utilities in there is to extract curves from the STL, and we can extract the curves that are from a plane and where that plane intersects this STL file. And we can see now we have a whole bunch of lines in here, or edges. So I'll generate that operation, and now if we look and see, we have some curves that got created. If we maybe just hide this STL file for a second, and if we zoom in here, we can see that these curves are quite poorly representing what that geometry should look like in real life. That'd be a nice, smooth blend in there. So, that's it's just following the STL geometry, but we want to clean that up. So one of the ways that we can clean up this geometry is to go into the Repair tab, and there's Fit Curves. So this option allows us to select a bunch of curves that we would like to clean up. We can say we'd like to correct the tangency, so we get these tangent points showing up, and then there's a distance here that it's looking for how many points to combine in this operation. So, if we start increasing the slider, you can see that it's combining these points in a different way. So we'll leave it about right there and perform that operation. Now we see we have a nice smooth curve that represents what that should look like. And we can do a similar thing for all of these edges that are making up this inner ID. We can create those, and you can just go through here and clean up as needed for all these locations. So if we said that that's good enough for now, and we turn this mesh back on and zoom into this location, you can see that that's a much nicer curve that goes through the faceted data. However, this location, that should be a sharp corner, and we got a blend in there. Well, that's certainly easy enough to change. If we select on that surface, there's a feature in here called Fill, which will remove that blend. So if we click it once, or it moves it into a chamfer. If you want to get rid of that chamfer, click the Fill again, and it will move it into a point. So we can use the Fill operation to clean up this gear tooth profile that we don't need, because we just need one cross section that is going to be the OD of the gear. We'll come back later on and cut out these gear teeth. So we can grab all of the edges that we don't want to have in here, which is those, and we can fill them in. And you see now that by using the fill, we have one edge that represents the OD of this gear profile. So then lastly, if we want to create a surface from all of these edges that these edge loop that enclose the surface, we can use fill again on that, and that will create a surface. So now we have the 3D surface that we were looking for that represents the cross section of this gear that will eventually revolve around. So we have that feature, again by using the STL file as a guide to build this surface. The next thing that we will do is we'll put in the hole in here. So we can select the facets that represent the hole just by double clicking, and we can insert a cylinder into that hole. So we'll eventually subtract this cylinder from this surface that gets revolved around. So if we do that, we just want to make sure that the face of this cylinder is not coplanar with this edge or sunken in a little bit. So we just want to make sure that it goes through that geometry. And we can modify that by just simply using pull. And with the left mouse, I just drag in the white space and resize that to the size that I would like. Same thing down here, just pull that out. And if this diameter didn't happen to be the right size, you could just simply type in what you'd like it to be on the keyboard. Maybe that should be 9, So it's very easy to modify this type of geometry. Now we have that cylinder. The last thing that we're going to want to do is create a solid that represents this gear tooth cutter profile. So we can create surfaces that go through this profile. And we can do that by, again, simply just double clicking on these facets and then getting all the facets that make up that one profile through there. And then in the reverse engineering section, there is Fit Spline option, which will fit a spline surface through all of these facets. And you can see it just kind of arbitrarily extends beyond the facets that we've selected. Now, I could have selected all of the surface facets that make up this inside profile here. However, if we zoom in and see, the curve or this inside radius here likely would not be the same radius as it went all the way down through here, just because of the faceting that's in there. So what we're going to do is we're going to come back in later on and put in a true blend that it should be. So if we ignore those blends for now, and then simply insert a few more surfaces in here, with fit spline, now we see we have three surfaces that represent pretty much the complete profile that we're looking for. So let's turn a few things off here just to make this a little easier to see. Now we're going to turn these surfaces into a solid. So let's just clean up these surfaces a little bit. One of the ways we can do it is just kind of slice off the extra surface that we don't need that extends beyond this profile, and then we'll eventually come back in and create a solid in here. So we can trim off the surfaces, say just select a facet, and then we can insert a plane. And this plane, again, is going to be coplanar with the top of this gear tooth. We might just want to, for the same reason as we've done before, just move that up a little bit. So use the move tool, with the plane selected, drag the direction that we want to move it in. And it doesn't really matter, the distance as long as it's off the surface. And then if I hold the control key and then drag this down, that'll create a copy, just like the Windows file system for copying files. Now we have two planes we can use to cut the surfaces. So if I just turn everything else off here, we can slice these surfaces with the combine tool. So if I box select all of the surfaces I want to slice, click the object that I want to slice with, and then again I can box select the surfaces that I'd like to remove as the third step in this operation. Now you could leave those if you want, you don't have to do that. So select the surfaces, select the plane, and then I can individually click and remove them as well if I wanted to. So now we've sliced the surfaces so they're a little bit cleaner, and we can also intersect all these surfaces, because right now we need really the inside three faces that represent the cutout. We don't need all of this extra stuff. So if we use the Prepare tab, there is an imprint option which will go through and then find all of the intersections that we have. And then I will just perform that operation. And now if I just box select the surfaces that I don't want, highlight them, hit the delete key to remove them, now we have the surfaces that make up that gear tooth cutout. So see, we're getting pretty close right here, so let's just turn this into a 3D solid. We can do that by just simply closing off that side over here. So there's a blend tool that will just create a surface between some edges. We can also box select the edges like we did before. If we want to put a surface in, we can use fill, and fill will create a surface if the edges enclose a full loop. We can fill that again, and if we have a bunch of surfaces that enclose a volume, it will create that solid. So now we have the solid that we're looking for. And the last thing we said we would do is we just come in here and then put in that radius. So we'll just grab the edges, and if we want to put in a radius, we can do that with the pull tool. And the pull tool knows that if you select edges and then with the left mouse just start clicking and dragging, it'll create a radius. And we can use the space bar and then free up the ability to type in a number, and maybe we just set that to 0.75. So set it to a number that we know would be manufacturable, or you'd have a tool bit that would make that. So now we have all of the geometry components that we need to rebuild this gear. So let's go in and start off by revolving this surface. So we can revolve this surface, say about this center line. So let me just put in an axis that we can more easily use to revolve this surface. So if we'd like, we can use the pull tool again, and we're pulling this surface, and instead of pulling in a direction, we will pull around an axis, this being the axis, and we're going to go 360 degrees. So that's this full pull option. So now we have our solid axisymmetric geometry. The next thing we will do is cut out the hole. So we can do that with the combine tool. And the combine tool is really a boolean. It adds or intersects. So we want to slice this geometry with this hole, and then the intersection that it leaves, if I click once more, it will remove that intersection. And we still have that solid body that we don't need. Just hit delete to remove it. And now we have this hole, and we can create a pattern of these holes. We can do that with the move tool. Again, we will create a set of patterns from that surface. We will move the origin of the move location to the center, and we will just drag this around to create a pattern of holes. So once we do that, we get a pattern down here, and then the angle between these holes, we are going to have 30 degrees, and there's going to be 12 of the holes. So now we have the number of holes that we need. And lastly, we will create the cutout of the gear tooth. We'll use combine again, and we will slice this body with this body. Click again to remove the intersection, go into the outline, and delete that. And there is actually a pattern option right here to create a circular pattern. So if we select all of these faces here that we want to create a pattern from, and now there's going to be 63 of these gear teeth. So if we put that in, select the axis that we're going to revolve this pattern about, and we'll see that it shows what this is going to look like before we accept that. So we could check that the number of gear teeth look correct. So now that created all the gear teeth, if I turn that faceted mesh back on, we can see that that very closely lines up with the scan data. So the last piece here would be to put the little chamfer that's on each of these gear teeth. So we can do that by grabbing all of the edges that go around the gears, and then we can put a chamfer on those. So one of the nice things with SpaceClaim is that there's a selection portion to this, which allows you to select based on some logic. So all of the edges that are the same length, but if we did that, that's going to grab the top and bottom, which might be okay because there's a chamfer on both sides. But we could, just to make this a little bit faster, just grab all of the edges that are same length on this face right here. So now that we have all of these edges selected, we can use the pull tool, and we can pull, instead of creating a round, we can create a chamfer with an option, and then we'll just simply start dragging and pulling. And if you know what the value should be, you can always type that in as well, and we'll get a chamfer in there. Then just say that that's close enough for now. We can make it exact, but close enough for matching up on this top face. It doesn't match up very well down on the bottom here. If I turn off the mesh, you can see that that's where this chamfer ends, but it should really go up to the top here. So we could do the same thing. We could grab all of these edges, do the same thing, meaning pull the edge to the size that we want this to be. So we can grab all of those edges, pull, and this time we'll pivot the edge so we can, in a particular direction, which is going to be this vertical direction for right now. We could pull it up to, say, the point right here on this faceted mesh. So we can use the mesh to snap the geometry that we've created up to it. So now that happens to line up exactly. We could do that with these locations as well. But that's close enough for now. Let's say that we've pretty much reconstructed the geometry that we need. And some other things that you can always do, since this is a direct modeler and just allows you to click and make changes as you would like. If you click on this surface right here and see that it shows up that it's 1.88 as the radius. Well, maybe that should be say 1.75. Just simply change it to whatever you would like it to be, or what it would be in real life. Maybe it's slightly off just because of the faceted data that we worked with. Same thing with this inside diameter. 44.39, maybe it's supposed to be 44.5, let's say. So you can easily make any of the changes. And same thing, all these holes, maybe we wanted to, say, make this be a parametric model. Well, if we wanted to change all of the holes, again, we could select them with this select logic, where we could grab all, say, equal radius cylinders, and with the pull tool, we can make a change to all of the holes at once. You can type in what you'd like that value to be, and if you click this little P that's next to this, that will create a group, and that group is a parameter that will come into Workbench, and then you can update these parameters that you'd be creating right from the Workbench project page. So showing that we've taken an STL file, which is just a triangular faceted data geometry file, and we've used that as a template to rebuild our 3D geometry from it, and we've also been able to make different features parametric. So now that we have our geometry file, we could use this in a simulation.